let's begin our discussion on polynomials by defining exactly what a polynomial is. A polynomial is simply a set of monomials. You'll remember a monomial is just a single term. And an example of a single term might be 3x or 7x squared, or maybe just -1, where there's no plus or minus signs. But to get a polynomial, we're going to take these monomials and we're going to add them together. What we would like to do is go ahead and define then polynomials by the degree. Remember, the degree is the largest exponent within that term or set of terms. So let's look at an example of what we've seen before of x plus 1. X plus 1 we consider a linear polynomial. If we look at x squared plus 2x minus 1, we say that this is a quadratic polynomial. We're going to continue. If we have x to the third minus 2x squared and some other things at the end as a decrease, if we have a degree of 3, then we'll look at a cubic polynomial. If we have x to the fourth plus some x to the thirds, x squareds, and x's, we have a quartic polynomial. And then we'll finish with x to the fifth, but we could go on forever. X to the fifth is going to be a quintic polynomial. And these are our different polynomials that we're going to discuss in Algebra 2. We've already discussed our linear family and our quadratic family. So let's now move into the cubics, the quartics, and the quintics. We're going to see that their bases are pretty much coming back to a linear and a quadratic. If you think about a linear times a quadratic, we'd have an x times an x squared, which would give us a cubic. So what we're doing is, to get to the cubic, is multiplying a linear and a quadratic together. So let's look at a polynomial that's already been factored. So if I give you the factored form of x plus 1, and let's say x minus 2 and x plus 4. To write this in standard form, all I have to do is multiply these three together, which we've done in the past. So we're going to multiply or distribute x plus 1 to the first x minus 2. So we're going to multiply x squared. X times -2 is -2x. We're going to go ahead and also combine that 1x. So -2 and positive 1 gives us a -x minus 2. And we're going to bring in our x plus 4. Here we're going to distribute the x squared, the -x, and the -2. So we'll end up with x to the third plus 4x squared. Multiply the -x through, we get -x squared minus 4x. And we're going to multiply the -2 through. -2x minus 8. We can combine like terms. So we have x to the third plus 3x squared minus 6x minus 8. So we can see that we started with 3 linear terms being multiplied together, and we ended up with a cubic function. Notice we multiplied x and x and x, and we got our x to the third. In example 2, we're going to start with a cubic, and we're going to go ahead and factor it. So we have 2x to the third plus 10x squared plus 12x, and what I want you to do is to be able to factor this. Remember, the first step in all factoring is to look for a GCF. Our GCF for 2x to the third, 10x squared, and 12x would be 2x. So we're going to have 2x on the outside of our quantity, and we'll be left with x squared plus 5x plus 6. Remembering, if I distribute this 2x back through, I would end up with what I originally started with. Continuing to factor my trinomial, I have 2x times x plus 3 and x plus 2. And this is our factored form of this cubic function. We're going to be able to use this later on to be able to find the zeros or the solutions of our cubic or polynomial functions. So let's go ahead and look at example 3 where we actually do that. So if I give you a function f of x equal, and let's give it to you in the factored form at this point. So let's give you x plus 2 times x minus 3 times x plus 7. If I ask you to find the zeros, or solutions to this, we would replace your f of x with a 0. And now we have three things multiplied together to give us 0. If we have three things multiplied together to give us 0, then we know that 1, 2, or all three of them must be equal to 0. So we can go ahead and take x plus 2, set it equal to 0, x minus 3, and set it equal to 0, and x plus 7, and set it equal to 0. Looking at this and solving, we get x equals negative 2, x equals 3, and x equals negative 7. Since these are zeros or solutions, when we were to graph it, we should see that we cross the x-axis at negative 2, at 3, and at negative 7. Example 4, let's look at f of x equal to x minus 2 squared times x plus 3 to the third. Notice this squared tells us that we have 2 x minus 2's, and this 3 tells us we have 3 x plus 3's. If we set this equal to 0, then we know that we have 2 of the x minus 2's, but we don't need to solve that twice since the same solution is going to occur both times. Likewise, the x plus 3 set equal to 0 gives us x equals negative 3. We don't need to do that 3 times. However, it is useful to note that this has occurred twice and this has occurred 3 times. So we call this multiplicity. And we say that the multiplicity of 2, so 2 has a multiplicity of 2, and negative 3 has a multiplicity of 3. Finally, in example 5, let's look at giving you the zeros. So let's give you x equals 1, negative 3, and 5, and ask you to write the polynomial that goes along with those. Well, if x equals 1 is a solution, then from doing this with quadratics, we know that x minus 1 equals 0 is a factor. Likewise, x plus 3 equals 0 is a factor, and x minus 5 equal to 0 is a factor. So we can take x minus 1 from this factor, the x plus 3 from this factor, and this x minus 5, and set them equal to 0. Now, we're simply going to multiply these 3 together. Multiplying x minus 1 to x plus 3, we get x squared plus 2x minus 3. Remember that 2x comes from when we multiply x to 3 and the negative 1 to x. And also multiplying that answer by x minus 5. Multiplying x squared through, we get x to the third minus 5x squared. Multiplying 2x through, we get plus 2x squared minus 10x, and multiplying a negative 3 through, so we get negative 3x plus 15. Combining like terms, we get x to the third minus 5x squared minus 13x plus 15. So let's recall what we've seen at this point. We've defined a polynomial as simply a set of monomials added together. We've talked about our linear and quadratics. Now we're looking at cubics, quartics, and quintics. We should be able to take the linear function, factored form, and write it in standard form by multiplying it out. We should be able to see the factored form of a polynomial and factor it, taking out a GCF. We can find the zeros of a solution or solutions by setting the function equal to 0 and setting each of those factors equal to 0. We can also state the multiplicity of any of our zeros or solutions, noting that the exponent will tell us what the multiplicity is for each of our factors or solutions. And finally, in example 5, we saw where we were given the solutions and were able to write the polynomial in standard form.